p116 and types of chemical reactions. You need to know the names of the reactions and to be able to classify or predict the type of reaction. So here we go. The first type of reaction we're going to look at is what was referred to as a synthesis reaction. This occurs when two or more reactants combine in order to form one product. If you take a look at in a textbook, more than likely the general reaction or the way that this would be represented would be substance A reacts with substance B to form substance AB. And notice that there's only one chemical formula on the right-hand side of the reaction. So take a look. Here is an actual synthesis reaction. And if you take a look, you will see to the left of the arrow, you have two reactants. And on the right-hand side of the arrow, you only have one product. So your biggest clue that a reaction is a synthesis reaction is the fact when you only see one chemical formula on the product side. So to balance this, I have one S on the left, one on the right. The S's are okay. I notice I have two oxygens on the left, three oxygens on the right, so I have to use a common multiple in order to balance those. So in front of the O2, I will put a 3, so 3 times 2 makes 6 oxygens on the left. So in order to have 6 oxygens on the right, I need to multiply that 3 by 2, so I'll put a coefficient of 2. But when I put that coefficient of 2 in, it also affects the number of S's. So now on the right, I have 2 S's. When I go back to the left, there's only 1, so I'll put in a coefficient of 2. So now I have equal number of S's on the left and right and equal number of O's on the left and right. The second reaction is a decomposition reaction, and sometimes it's a little bit opposite of the synthesis reaction. So a decomposition reaction occurs when the only reactant chemically breaks down into multiple substances. So the general equation, it would look that you might see in a textbook. You would have substance AB and it breaks down into A plus B. So we start off with one reactant and we end with more than one product. So when you take a look at the example reaction here, to the left of the arrow, there's only one reactant. And to the right of the arrow, there are multiple products. Meaning there's more than one product. So when you're on the left-hand side of the arrow, if you only have one reactant, that's your biggest clue. It's a decomposition reaction. So let's take a look. Let's make sure that our example reaction is actually balanced. Hg on the left, 1 Hg on the right. So that looks good. On the left, I have 1 oxygen, but on the right, I have 2. So I need to increase my oxygen count on the left. So I'll put a 2 in front of the HGO. And I have 2 oxygens, but that also changed my Hg from 1 to 2. So I need to increase my number of Hg's on the right to a 2. And then I understand that I only need 1 mole of oxygen on the right. Moving on to the next example is a single replacement reaction. So single replacement reactions will occur when the atoms of a free element replaces the atoms of an element in the compound. So the general equation, if you were to look in a textbook, you would have substance A wanting to react with BC. So in this case, A would represent the element and BC would represent the compound. A wants to replace or kick out one of the partners in the compound. If it's successful, right, then our new free element would be B, and the new formed compound would be AC. So we end up with a different free element and a different compound. Now, does every free element react with every compound? No. So you will need to learn to use your table J to determine if the reaction can actually happen. So I have a clip of your table J here in the notes. One list is made up of metals or things that are to the left-hand side of the stair step on our periodic table, and the other list is non-metals, things to the right. So here we go. Let's take a look here. The free element must be more active than the element in the compound for the reaction to happen. And the way that you can tell that it's more active by looking at the list is that the free element will actually be higher on the list than the element in the compound. The free element, it only replaces an element from the same list. So you can't have the free element from the left list replacing something from the right list or vice versa. So when we take a look at this setup, NaCl represents the compound and Li represents an individual element. So Li wants to replace one of the partners in the compound. So when you go take a look at your table J, you will notice that Li right here is a metal, and Na and Cl, Na is right here, but Cl is in a different list. So Li would like to come in and it would like to kick out NaCl. So what you have to think about is, how does Li's activity compare to Na? Li is higher on the list than Na, so Li, lithium, has a greater activity than Na. So the reaction happens. So lithium will kick sodium out of the compound, so our new free element will become sodium, and the new compound will now be made up of lithium and chlorine, so LiCl, lithium chloride. So you take a look at the next example. Our free element is magnesium, and we can take a look, and magnesium is right here on the list, so it's the list in the metals, and magnesium wants to try to kick out either Na or Cl. So when we look at this list, Na is in the same list as Mg. So Mg would like to kick sodium out. They're in the same list on table J. So you have to think about comparing their activities. So magnesium being the free element, how does its activity compare to Na, what is in the compound? Well, magnesium is lower than Na on the list, so magnesium is less active than sodium. So when the free element is less active, that means there is no reaction. No reaction occurs. If you have to explain it, explain why this reaction will not occur, you want to keep a very simple statement. You would simply state that magnesium is less active than Na, so it cannot replace it in the compound. Looking at our next example, now our free element is fluorine. So take a look. In the first list of metals, Fluorine is not here, so move on to the next list. Oh, right here is fluorine. So fluorine wants to be able to kick out one of the partners. Well, this is a short list. The only partner in the compound that's in the same list as fluorine is the chlorine. So fluorine would like to come and kick the chlorine out. So in order to do that, you've got to think about the activity, right? So how does the fluorine's activity compare to the chlorine? Fluorine is above chlorine, so the fluorine is more active than the chlorine. The reaction happens. So the new free element is chlorine. Now, chlorine's a diatomic, so we have to write its chemical formula as Cl2 as a free element. And the new compound is sodium fluoride, so that would be NaF. We would have to do a little balancing because we don't have the same number of chlorines on each side. So if we put a 2 in front of the NaCl and then a 2 in front of the NaF, now we have a balanced reaction. Last example here. So in this example, we have the element iodine, and it wants to be able to replace one of the partners. So when we take a look and find iodine, here it is. Iodine is in the same list as chlorine. So iodine wants to be able to kick chlorine out. But you have to think about their relative activities. Iodine is lower on the list than chlorine, so it's not as active. So iodine is less active. So since iodine is less active than chlorine, no reaction. Iodine cannot replace chlorine in this compound. So if you had to write an explanation, you would simply write that iodine is less active than the chlorine. So there's no reaction. Moving on to page 116, where there's a double replacement reaction. So a double replacement reaction occurs when two aqueous solutions exchange, or I like the word swap,